d. And the other thing that you need to know is that we assume the masses to be point masses. So if I could replace these planets with a point, my answer shouldn't really change. Okay, so that's the formula we saw last class, and we'll be using it here as well. So এখন জিনিসটা হচ্ছে these are two masses here, m and small m, and if I want to know the forces between them, we can now find it, right? The forces given by F. So the two forces are equal and opposite and everything, right? Now, the thing is, I'll record this.
Recording in progress.
Right. So, এখন জিনিসটা হচ্ছে, how do you compare gravitational fields? So I'll ask you a few questions and see if this can solve our problem. So let's say there's planet A here. This is a planet, planet A, and there's another planet out there, planet B. So we want to compare the strength of the gravity of these two planets. এটা compare করতে যাচ্ছি, okay? আমাদের কিন্তু জানা নাই প্ল্যানেট গুলো দেখতে কিরকম. We just know that, we don't have any other information other than the fact it's planet A and planet B, right? Now, we have another piece of information. Listen carefully, okay? And I want you guys to try to answer this. We have another piece of information, which is there is a mass on planet A, right? What is it? We do not know. There is a mass here that experiences a force due to the planet, the weight, right? And that force due to planet A on that mass, right, is 4,000 Newton. That's the force being exerted by planet A on that mass. We don't know what the mass is. There's another mass here on planet B that experiences a force due to planet B, and the force is 7,000 Newton. Okay, 7,000 Newton. Now, can you tell me, based on the information I've provided here, right, can you tell me which planet has a stronger gravitational field around it? And out of the two planets that I've provided you, which one has a stronger gravitational field around it? Is it planet A or is it planet B? Car gravitational field is stronger. Is it planet A? Is it planet B? Or we can't say. Based on the information provided, it's not possible to say. So what do you guys think? Which planet has a stronger gravity? Right. No. So that's the thing. I'm কিন্তু কোনো সময় বলি নাই at this, I gave you the question, right? I haven't said that even once that these masses are same. এটা কিন্তু বলি নাই. I said যে planet A এর উপরে একটা mass আছে, some mass which experiences 4,000, and planet B has some mass we do not know, some random mass which experiences 7,000. So which one is a stronger gravitational field planet? Is it planet A or is it planet B? So yeah, some of you figured it out. The answer is inconclusive, not possible for us to say. So using what value here? Using the force value, using the value for just F, we cannot determine the strength of the planet's gravitational field. So just by using the value of F, it is not possible to find the strength of a planet's gravitational field. It's just not possible. Why? It is because, I'll tell you why it's not possible. It is because this planet A here might be experiencing or exerting 4,000 Newton on what happens to be, in this particular scenario, a mountain. So it's like a mountain that's here. So এটা একটা জিনিস, আর এখানে this planet B is exerting this force, উল্টাটা করি, sorry, এটা mountain, and this one is like a small car. Acha, so planet A applies 4,000 Newton on a car, and planet B applies 7,000 Newton on a mountain. Can you now tell me which planet has a stronger field? এই কনটেক্সটটা দেওয়ার পরে ডেফিনেটলি কেন এই একটা গাড়ির উপরে 4,000 দিচ্ছে আর এই প্ল্যানেটটা অন আ মাউন্টেন রাইট মাত্র 7,000 দিচ্ছে, সো তার মানে কি এই প্ল্যানেটের গ্র্যাভিটেশনাল ফিল্ডটা স্ট্রং না। And that's only possible. You guys answered it, right? How did you figure it out? Because I gave you context here that this is a car and this is a mountain. তাহলে তোমাদের ইজি হয়ে গেছে বুঝতে যে আচ্ছা wait a second. So there's a car here that experiences 4,000 on this planet, right? And there's a mountain on this planet, like an proper mountain that only experiences 7,000 Newton force. I mean, the gravity though must be very weak, like the moon. Moon and everything is 1/6 that of the Earth, right? So as you see, the force is actually not a conclusive answer. So what would have been a conclusive answer? So let me show you. So this could have been better done if we did something like this, where I told you, same scenario, সবকিছু same, the planets are same, the force and everything. But I told you the amount of force that was exerted for কি হতে পারে, তোমাদের কোনো আইডিয়া আছে কি বললে তোমাদের জন্য জিনিসটা ইজিয়ার হতো? Like what should have I said that would have made your exactly the mass? And আমরা যেটা করব এখন, we will compare the force, right, for the same mass. So দুইটা planet নিব আমরা and we'll compare the force for the same mass. What mass? It's called a unit mass. A unit mass মানে হচ্ছে 1 kilogram. So we will compare the force for 1 kilogram as a reference. যে একটা 1 kilogram mass যদি থাকে প্ল্যানেটের উপরে, what force should it experience? And then we find that planet A has a force of 14 Newton for every kilogram. And planet B has a force of 2 Newton for every kilogram. Now, if I just told you this value, forget the planets, don't forget how they look like, what shape they're, mountain, car, whatever what we said, right? Forget everything. And I just told you this one piece of information. The planet A applies 14 Newton for every kilogram, and planet B applies 2 Newton for every kilogram. Will you now be able to figure out just by using this information which one is a stronger field exerting planet? Yes, it's very easy, right? It's just A here. And this quantity that you're seeing here right now, this one তোমরা আগে থেকে করে আসছো. I built it up this way because আমাকে আবার শিখাতে হচ্ছে. I'm not really sure সবাই জানো নাকি, but there's a name for this quantity. The amount of force exerted per unit mass. Do you guys remember what that was? It was there in your levels. The amount of force exerted per unit mass. Right, it is called gravitational field strength. And this is what you refer as like small g. G equals to 9.81 zeta, oita. So gravitational field strength is this idea. So what is gravitational field strength? It is the amount of force experienced per unit point mass in a gravitational field. তোমাদের সিলেবাসের মধ্যে ডেফিনিশন গুলোর মধ্যে পয়েন্ট মাস অ্যাড করে দিও সবসময়, যে মাস গুলো তো র্যান্ডম শেপ এন্ড সাইজ হতে পারে, আমরা অ্যাজিউম করে নিব পয়েন্ট মাস. So it is the amount of force experienced per unit point mass in a gravitational field. The unit is Newton per kilogram. This quantity is called gravitational field strength. And now onwards, whenever we want to compare gravitational fields, right, আমরা যখনই গ্র্যাভিটেশনাল ফিল্ড কম্পেয়ার করব, আমরা এই ভ্যালুগুলো কম্পেয়ার করব. And you guys have learned this very well. O levels এ ছিল, একটু রিক্যাপ দেওয়াই. O level might seem very long time back, but মনে রাখতে হবে তো জিনিসগুলো. So let me give you some examples. So this is your Earth. Earth. And you have your moon. This moon. And we'll add Mars here. So Mars. So this Mars. Let's try to figure out whose gravity is strong and whose gravity is weak. Okay, let me draw this. So yeah, আমি ভ্যালুগুলো বলি তাই তোমরা জন্য easier হবে বুঝতে. This is Mars, Earth, and Moon. Can you guys tell me what is the value for gravitational field strength for Earth? Very obvious, but I just want to see if you remember or you know what I'm talking about. So what is the gravitational field strength for Earth? মানে হচ্ছে, what is the amount of force that the Earth exerts on a 1 kg mass? 9.81, correct. 9.81 Newton per kilogram. What's the value for G for the Moon? Moonটা কি মনে আছে কারোর? Yeah, the G for the Moon was how much that of Earth? এগুলো all levels ছিল কিন্তু I'm not doing anything new here. I'm just trying to relate to things you have done before. Yes, it's 1.6 Newton per kilogram, basically 1/6 the value. And Mars একটা বলি তাহলে তোমাদের একটা আইডিয়া হবে. So Mars, এখন তোমরা একটু দেখো পারো নাকি জিনিসটাকে imagine করতে, okay, or figure out করতে through an educated guess. Mars is about half the size of Earth. Do you think the value for the G, the strength of attraction for Mars, should be more or less than that of Earth? Mars is a smaller planet. It should be less, right? No, it is less because mass to come. And isn't the attraction based on mass, right? So Mars, if I'm not wrong, is 4 point something, I think 4.5 মনে হয়. Yeah, approximately something like that, 4.5 Newton per kilogram. So do you see that just by looking at this value, it's very easy for you to figure out how the experience of gravity would be on those planets. So Earth হচ্ছে 9.81, Moon হচ্ছে 1.6, Mars হচ্ছে 4.5. To give you context, এটা কি মিন করে, আচ্ছা, তুমি যদি আর্থে একটা বল হচ্ছে আকাশে ছুঁড়ে মারো, রাইট, এই যে বল একটা আকাশে ছুঁড়ে মারলা, এই বলটা উপরে গিয়ে নিচে নামলো, রাইট, তোমাদেরকে একটু জিনিসটা অ্যাকচুয়ালি দেখাই. So how does gravity affect motion? So আমরা projectile motion করে আসছিলাম back in our AS, right? More fresh কিছু একটা দেখাই তোমাদেরকে. So projectile motion, and what I'll do right now is I'll fire this thing up, and you'll see how gravity affects them. So আমার পাশে একটা gravity slider আছে, okay? So this is Earth, 9.8, একটু কম হবে, 9.81. Yeah, so look at this. So yeah, this is the path taken on Earth, right? Moon যে আমরা 1.67, আচ্ছা মুনে যেতে দিচ্ছে না. So it's like Mars. What do you guys think? Do you think the ball will go further or fall closer on Mars? I want to see, can you imagine what's going on? So Mars যদি একজন কেউ ফুটবল কিক করে, will it go further or will it fall closer? Yes, very good. See, it'll go further, the gravity is weak, right? And because the gravity is weak, the ball will take longer to come down, right? And see what happens. You would be breaking, like, world records on Mars, but it our world record হবে না, it'll be probably Mars record. But the point I'm trying to say is that you can see that it goes way, way further, right? So, and Moon to, it's going to be even further. In fact, there's a story, they actually played golf on the moon, and the astronaut গুলো গেছিল, and the person who hit the golf ball, right, very bad golfer, মানে barely ball মারতে পারে, the ball traveled like the whole golf course on Earth. Just imagine a whole golf course, 18 holes, pura distance travel course. So that's because the gravity is very weak there. So this is the value. So this value that you see here is like that. So Jupiter যদি যাও, Jupiter কি হবে? Can you tell me? Jupiter, if you throw a ball up in the air, right, where will it go and fall? Yeah, it'll fall in front of you. দেখো কি হয়? There. Okay. So it's the gravity is very strong, and it's like everything is coming down very fast, so it barely stays out there. So I hope you understood what that value of G does. So এখন এগুলো কিন্তু হচ্ছে not new stuff for you. এটা ও লেভেলস এ হচ্ছে অ্যাস্ট্রোফিজিক্স এ ছিল. আমাদের নতুনটা কি হবে এখানে? So the new thing is how to find gravitational field strength for a planet. এই যে 9.81, তারপরে 4.5, তারপরে 1.67. How do you find these values? So this is a derivation. It's there in your syllabus. Deriving the equation for G. Okay. So gravitational field strength. Right. So how do you derive the equation for gravitational field strength? Let's see. So first of all, gravitational field strength, did you know there is a definition, right? It's the amount of force exerted per unit mass. So আমরা definition টা নিয়ে কাজ করব. So what does the definition tell us? So according to the definition, gravitational field strength, sorry, take লিখে একটু. কেউ কি আমাকে একটু বলতে পারবা যে কি হতে পারে ইকুয়েশনটা? Because you guys are A2 students, তোমাদের definition থেকে ইকুয়েশন বের করাটা shouldn't be a difficult task. So gravitational field strength G, right? Based on the definition, ইকুয়েশনটা কি হতে পারে? Reverse engineer করতে পারবা প্রসেসটা? What should the formula be? It's the amount of force per unit mass, right? How would you write this in the form of an equation? What do you guys think? Small g হচ্ছে gravitational field strength symbol. So কি হতে পারে ফর্মুলাটা? Yes, it's force by mass. Very good. Force by mass, because it's the amount of force exerted per unit point mass or mass, right? So this is the formula. So এটা দিয়ে কাজ করবো. এটা, by the way, is a formula for gravitational field strength, a generic formula. And anytime you find gravitational field strength, this is the formula you use. And I don't know if you have realized this, a formula তোমরা আগে use করছো. Does anyone know which formula is this that we are talking about? A G equals to F by M, right? Which is that formula that you have used this previously. To different way use course, but use course. Right, exactly. W equals to mg. So what a force to force, right? Force we call it weight, because the force of gravity is known as weight. Mass to mass are g to gravitational field strength. So that's the formula that you have been using. This is the origin of it. Okay. Anyways, এইটাতে আমরা পরে আসতেছি. So G formula হচ্ছে force by mass. এখন derivation করি. Like how do we find the value, right? So look at this. Carefully observe করো. Easy essay. So first of all, G is equal to F by M. And I want to find the gravitational field strength of this planet whose mass is M. Okay, or mass M. And we are trying to find the gravitational field strength at a distance from this planet. মানে তুমি প্ল্যানেটের যদি কোনো একটা ডিস্টেন্সে যাও, somewhere away from this planet, what is the force or what's the strength or যে জায়গাটায়? So the distance is d. So the formula is going to be G equals to the force between the planet and whatever mass is there. So let's take a ছোট mass assume করলাম. So it's going to be formula কি G M M divided by d square. এটা কিসের ফর্মুলা? এই যে ফোর্সটা, that force, right? Divided by m. স্টুডেন্টদের কনফিউশন হয়, এই m টা কোনটা? This m, is this the m that applies the force, or is it the m on which force is exerted? That's the confusion. Okay, আবার বলি, is this mass here এই ইকুয়েশনের মধ্যে the mass that exerts the force, or is it the mass that experiences the force? So I'll help you out here with this equation. Weighter মধ্যে, is W the mass of the object exerting gravity, or is M, sorry, J, weighter M, is it the mass that experiences the force of gravity? So কোনটা হয়? Is it exerted or is it experiencing? Yes, it's experiencing, right? So in this scenario, who's experiencing the force of gravity due to this planet? A small m there. So এখানে small m টা দিয়ে divide করবা, and you'll find that the masses cancel out. Now, some students don't understand this or have confusion. ওদের জন্য একটা simple solution আছে. Remember what we considered our mass to be for the derivation or the equation there, 1 kg. So তুমি চাইলে এটাকে 1 kg নিতে পারো. তাহলে 1 মিলে cancel out হয়ে যাবে. But you know, eventually you're basically taking the same mass here. যাই mass now cancel হয়ে যায়. And as a consequence, gravitational field strength formula হচ্ছে Gm divided by d square. And let me give you a heads up. If there's one equation in the whole chapter of gravitation that is the most important, it is this one. And I'll show you why right now. So gm divided by d square. This is the formula for gravitational force. Sorry, gravitational field strength. This is the formula for gravitational field strength. And one single most important equation in the whole chapter is this one. So এখানে কোনটা কি একটু বলি. This is your gravitational field strength. Gravitational field strength, যেটার ইউনিট হচ্ছে Newton per kilogram. If you want, you can put the minus sign here as well because of attraction, but math use করবো না আমরা. G হচ্ছে universal gravitational constant. M হচ্ছে mass that exerts the force. আর D হচ্ছে the distance between the mass's center of gravity. Okay, distance between center of gravity. If it's gm by d squared, then it would be the force exerted by the small. Yeah, exactly. So তুমি যদি এটা হচ্ছে small m দিতা যে g small m by d squared, তাহলে হচ্ছে তুমি ওর gravitational strength বের করতে পারতা. You're right. So yeah, that is the equation. Gravitational field strength, definition and everything is provided here as well. So that's the formula, gm by d square. Okay, so to যা চাও কপি করে নাও, বুঝে নাও, আমাকে কোনো কোয়েশ্চেন থাকলে করো. This is very important equation. এটাতে এইখান থেকে স্টার্ট করে যত কোয়েশ্চেন আমরা করব এই ইকুয়েশনতে থাকবে. সো সামটাইমস স্টুডেন্টস হ্যাভ আ কোয়েশ্চেন দ্যাট তাহলে এটা কি দরকার, এই ফর্মুলাটা তো আছে, why do we need this? So the flaw with this equation is that it only helps you find forces and interactions when you know both the masses. But what if you have only a planet and you want to know how the field is varying around it? Just the field around it, not any other planet. The strength of it on its own. তাহলে এইসব ফর্মুলা কাজ করে না, তখন তোমাকে একটা ম্যাথ নিয়ে কাজ করতে হবে. সো তুমি যদি এই ফর্মুলাটা ইউজ করো minus gm by d square, you can investigate the strength around a single planet or mass on its own. You're not relying on some other mass to exert its influence, right? So এটা চারিদিক দিয়ে কি হচ্ছে ওটা তুমি জাস্ট এই ইকুয়েশন দিয়ে বের করতে পারবা. I'll show you more examples of it soon, but এই জিনিসগুলো বের করতে পারো তোমরা, these values. So এই values গুলো বের করার জন্য এই ফর্মুলাটা লাগবে. Right. Then what will be the value for distance if it's only a planet? Also, you want to know how much is the strength at that point from the planet, so we can cut distance way over, because if you go to different places, wouldn't the strength vary? So whichever location you want to find the strength at, you take that distance, because there's no value for a planet. There's a value for a planet at a location, like the surface, some distance away from it, some location away from it. So there are values for different places around a mass. So you just take the distance of that particular location, and then from there you can find your answer. By the way, তোমাদের কি AS result হচ্ছে এই day after tomorrow? No, 13th. That's okay. All right, let's last class class recording to মনে হয় নাই, because last class to me physically নিছিলাম. I took online version of it, but I don't think I have a class record. I'll check though. মানে most likely থাকার কথা না. আচ্ছা, আমরা কিছু questions করি to see how to apply this idea. So first question for you guys is this one. আমি এই কোয়েশ্চেনটা উপরে রেখে দিলাম, but this is the question. Find the gravitational field strength at the surface of a planet. What planet, right? So planetary mass and everything provide for the chi. It's a planet whose mass is 5.7 into 10 to the power 20, sorry, 6.02 into 10 to the power 24 kilogram. This planet has a radius of 6380 kilometers, and your universal gravitational constant is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So তোমাদের যেটা বের করতে হবে for me is যে প্ল্যানেটটা বললাম ওর সারফেসে what is the strength of your gravitational field? Okay, so you have your planet here. I'll try to record the classes because net আমারও সাইডে মাঝে মাঝে থাকে না ঠিক মতন, so yeah, I'll record it আজকে তো করতেছি. So radius এটা, so at the surface of this planet what is the strength of gravity বের করো. Can you explain why you added a minus? Oh, আচ্ছা, এটা হচ্ছে মাইনাসটা হচ্ছে a sign that we use in physics to show attraction. So কোনো একটা ফর্মুলার মধ্যে যদি একটা মাইনাস সাইন থাকে for force, right, it means that the force is attractive in nature. আর যদি প্লাস মাইনাস দুইটাই থাকে তার মানে হচ্ছে it's attractive and repulsive. আর যদি খালি প্লাস থাকে and minus not possible, then it's only repulsive, which doesn't exist out there. So gravitational force is only attractive in nature. We saw that the other day. So because it's only attractive in nature, a minus sign take রাখা হয় to show the fact that it's only attractive. Math করার সময় লাগে না, but this is something they use as a symbolic sign. So yeah, can you find the gravitational field strength at the surface of this planet? A planet's surface. And এটা একটু বের করো, 140 kilometers above the surface কত আসে? That's the second question. Okay, 9.86. আচ্ছা দেখি. So G surface is equal to 6.67 into 10 to the power minus 11 into mass of this planet 6.02 into 10 to the power 24 divided by the radius of the planet 6380 into 1000, because meter to kilometer squared, meter to kilometer, no sorry, kilometer to meter. So এটা করলে কি আসে? এটা করলে কি 9.86? Right. So 9.86 Newton per kilogram. This, by the way, is the Earth. Okay, so Earth's surface G value বের করলা. Now, what is the value for G at 140 kilometers? So it's going to be the same thing. Data. So এই জিনিসটা সেম থাকে, right? Divided by তোমার হচ্ছে 6380 plus 140 into 10 to the power 3 পুরোটা squared. It's 9.45. Okay, 9.45 Newton per kilogram. So do you see that the value of G barely changes? 9.86 to 9.45. What is this 140 kilometer reference point here? This is the location at which you have your satellites, like the International Space Station and all those things. So, you know, when you see a picture of this International Space Station moving through space, right? You feel like the gravity is zero there. Gravity is not zero there. It's 9.45, and it's so much that you wouldn't even realize gravity is weak. ওকে, মানে গ্র্যাভিটি ওই ভ্যালুটা তোমার বডি এক্সপিরিয়েন্সই করতে পারবে না। So do you see how the distance is 140 kilometer, very large distance. It has very little impact on the value, right? So yeah, this is the reason why you have to go really, really far out in space to actually experience low gravity. But zero gravity could be unlikely because there's always some other mass around you exerting gravitational force. Right. So why do they float? Good question. Or float করে কেন এখানে? So the thing is, um, it's Newton's first law and second law সব মিলে আমি একটু এক্সপ্লেইন করি কি হচ্ছে। So let's say you're in the International Space Station. আচ্ছা, এই যে যেটা যেটাতে astronauts go and float. আমি ছবি দেখাই if somebody doesn't know ISS. Right, this where they go in space. Or এটাকে wrong নাম দেয় একটা zero gravity. So this is actually wrong. There's no zero gravity there. The gravity is actually 9.45. So why is it that these, right? Look at everything floating there. So question হচ্ছে, why are these floating? এই এই সবকিছু ফ্লোট করতেছে কেন? এখানে কোয়েশ্চেন আসার চান্স কম তোমাদের, because Cambridge doesn't ask these kind of practical questions. Cambridge খালি straightforward খালি math দিতে থাকে আর some basic definition. But is there anyone who can explain to me why are they floating? Just as a reference, আমি এখানে বলে দিই g value কত. They are currently experiencing a value of g that's 9.45. এই যে এখানে g ভ্যালু হচ্ছে 9.45, তাহলে ওরা ফ্লোট করতেছে কেন? Yes, exactly. There is no reaction force acting on them. So এটা হচ্ছে সার্কুলার মোশন থেকে হচ্ছে, they are undergoing circular motion. আমি আরো better example দিচ্ছি in a bit, but যেটা হচ্ছে, this is International Space Station, right? And this International Space Station is going around the Earth. And as it goes around the Earth, there's a force acting downwards, which is what? The weight of the Earth, and a weight exerted by the Earth, W. And you have your astronauts here as well. And ওদের উপরেও there's a force downwards. Now turns out that the International Space Station is going at such a rate, at such a location, in such a way that all of the centripetal force is provided by the weight. Now, do you remember that if you were in or anywhere on any surface, what was the uh, formula for all the forces, or what was the interaction between all the forces acting on you? That there's a reaction force here, and because you need centripetal force downwards, what would the equation be? W minus R should be equal to FC. Do you agree with that? If this is the Earth, by the way, right? So the centripetal force নিচের দিকে point করবে. So shouldn't it be W minus R equals to FC? Now the place where this International Space Station is, it's by design, by the way, or ইচ্ছা করে করে এটা. So the place where they are, ওইখানে হচ্ছে the W is such that it's exactly equal to FC. So what should your reaction be equal to? Zero. And zero reaction means no contact. So essentially, the people in the International Space Station are falling towards the Earth, and the International Space Station is also falling towards the Earth at the same rate. And because they both are falling at the same rate, the people inside don't experience any reaction. And because there's no reaction out there, they're basically just floating around. But the value of gravity is not zero there. It's actually 9.45. So imagine that the person, a International Space Station যে জায়গায়, ওইখানে person থেকে রিলিজ করা হলো. Let's say we just release a person into space, okay, at the location of International Space Station. He's not moving, মানে ওকে জাস্ট ছেড়ে দেওয়া হলো, ওর কোনো velocity বা কিছু নাই. Can you tell me what will he be doing? Will he fly out into space? Will he just float there, or will he come crashing back to the Earth? So you just release him, বুঝছো? You're not throwing him. throwing him মানে হচ্ছে যে ছেড়ে দিলা, so he's like having a velocity. It's not that. He's at zero velocity. So if he's at zero velocity, will he continue to orbit the Earth, or will he just fall back to the Earth? So the answer is he'll fall back to the Earth because there's a force acting on him right now. And what is that force? Gravity. And how much is the force going to be? W equals to mg, where g is going to be 9.45, which is almost like a person's weight jack. Correct. So essentially, he will just fall back to the Earth. But here's the problem though. International Space Station থেকে যখন লোকে বের হয়, like they do spacewalks, right? So ওরা যখন বের হয় তখন দেখা যায় they're floating in space. So they're not really floating in space. They're flying in space with the space station এভাবে যাচ্ছে তারা in orbit. So they become a satellite on their own. Because according to Newton's first law, if you're in a object that's moving at a speed, ওই object থেকে বের হলেও you still maintain that speed. So if anytime, for any reason, somebody loses contact and or tarta ছিঁড়ে গেল এখানে, he will not fly away into space as they'll show in movies. He'll actually fly with the station. Until, let's say, he does something that creates a change in momentum and then he flies away. And generally ওটা করার জন্য they use like boosters. পিঠের মধ্যে একটা জেট প্যাক থাকে, ওটাতে কিছু গ্যাস বের করে, and ওই গ্যাসটা হচ্ছে একটা momentum generate করে, and they fly around. That's how they fly in space. এটা করে ওরা. Okay. Anyways, I was just answering that idea যে কেন হচ্ছে তাহলে people are floating there. So yeah, the gravity is not actually zero there. In fact, there's no zero gravity in any close vicinity around our Earth. There's a location যেখানে zero gravity net value পাওয়া যায়. আমরা ওটা শিখবো. It's a null point between the Earth and the Moon, very far away. ওই জায়গায় গেলে you'll get a zero net value. আচ্ছা, I have another question for you guys. এখান থেকে ম্যাথ আসে অনেক এক্সামে, so এটা একটু চ্যালেঞ্জিং. Okay, so I've given you the easiest question out there. Now I'll give you the most challenging one. I think I have seen. Challenging because খুবই straightforward question, but স্টুডেন্টরা একটু struggle করে. এই যে এটা দেখো কি, the planet. So listen carefully, okay? এখানে wordingটার জন্য স্টুডেন্টরা struggle করে, not because their ability of understanding the topic is understanding the question that's the problem. So planet has radius r. So you have this planet whose radius is r, and the mass m. So planet mass m, and gravitational field strength g at the surface, or g value. Another planet of the same material. So our planet is the same material, much bigger. Okay, 3 times bigger. So that's the other planet. 3 times bigger. Its radius is 3r. So radius here is 3r, and or value key g. Eta বের করো. So if you go to this new planet, right? So just imagine this. Earth থেকে 3 times the size of Earth that the planet exists for. Okay, it's like 3 times the size of Earth, but it's similar to Earth in composition. And it's not a gas planet, it's not a metal planet, it's just like Earth. Okay, so it's a mixture. So if Earth were to be 3 times bigger, what would the value of g be on the surface of the Earth? একটু ট্রাই করে দেখবো কি আসে. Right. So Mursaleen, I think you are. আচ্ছা না, তোমারটা হয় নাই. Tasnia, I can't answer that question because that is the answer to the question. Ragib, that's not the answer. Yes, Hadin, that's the answer. Very good. So বাকিরা ট্রাই করো, একজনের তো অ্যান্সার আসছে, বাকিরা পারবে আশা করি। No, it's not that either. Yes, Anaf, you're correct. Mm, uh, can you give the answer in terms of G? Because it is not Earth, Kintu. I just give Earth as an example for context, but this planet is not Earth. So just give me in terms of G. Yes, হয়েছে অনেকেরই correct answer আসছে এখন. The correct answer is করে দেই, okay. Correct answer is 3G. কেমনে? So we know that the formula for gravitational field strength is small g equals to gm divided by d square. এখন the thing is, আমাদের distance to 3 times বাড়ছে, and some students will go like, oh, that's 3 times increase, so 3 square করলে 9 times হবে, কমে যাচ্ছে. But the problem is, isn't it a bigger planet? So bigger planet হলে mass কি same থাকবে নাকি mass বেড়ে যাবে? So of course বেড়ে যাবে, right? So if I give you a lump of Play-Doh, right? And Play-Doh থেকে কি করলে একটা ছোট ball বানালা using the Play-Doh, আর একটা বড় ball বানালা using the Play-Doh. Do you think the bigger ball will have less mass or more mass or same mass? Should be more mass, right? Because more material. So the question is, how much more mass? So ওটা বের করার জন্য আমি এই ফর্মুলাটা ইউজ করব, ডেনসিটি ইকুয়ালস টু মাস বাই ভলিউম, যেহেতু সেম মেটেরিয়াল বলছি আমরা. So density is same, and mass is density times the volume. Now let's try to understand how much is the increase in volume here. So density into volume হচ্ছে 4/3 pi r cubed, right? So আমার যদি radius 3 times বাড়ে, this is going to be 3r cubed, which is going to be 27 rho 4/3 pi r cube. So আমার হচ্ছে 27 times increase হচ্ছে mass. This mass is 27 times more. So there's an increase in mass of 27 times. So যদি এখানে equation বসে g times 27m divided by 3r square, right? So 9d square. আমরা এখন যেটা বের করব, we'll take the constants out. So you get 27 by 9 times gm by d square, and that cancels out to give you 3, and gm by d square g যেহেতু 3g. So it's going to be 3 times the gravity of Earth. So on this planet, your weight would be the same as a cow, like an actual cow. Okay, so a planet যদি থাকো, your weight, not your mass. Right, so there you go. This is a question Arsonicke, so well done, because it means you know how to apply the mass concept as well. But the problem is what, sometimes they'll say it's just a bigger planet, and they say nothing about the size or material or anything. So তখন একটু confusion হতে পারে যে maybe the planet was expanded, like expand করছে, তাহলে আবার কিন্তু mass same থাকবে. So some students assume that oh, it's small planet, it became big. No, it's just another planet that's bigger in size with the same material, so it's gonna have more mass, right? Anyways, that's gravitational field strength. So our next class যেটা করব, again, I hope I can take the class upfront, or networkটা ভালো থাকবে. It's the graphs of gravitational field strength, like graph, and we have plenty of graphs in A2. Like I can make like a 20-page book just on graphs, which I do at the end. I give you like a document with all the graphs that we have. So there's way too many graphs here. এইখানে graphs গুলো start হয়. Okay, we haven't seen any proper graphs yet. This is the chapter where we start. এই যে এরকম graphs. So এটা আমরা next class start করব. Okay, meanwhile I'll upload these. Just go through and see if you have any issues regarding gravitational field strength. Okay.